Welcome to Food Technology 1, FOT 150S. Today we are going to be talking about a refractometer and how we can measure the sugar or in some cases salt concentrations using a refractometer. So there are two types of refractometers that you can find. So we have what we call the digital refractometers. So the digital refractometers will give us a number or a value digitally, and we also have what we call the handheld refractometers. So the handheld refractometers, they also have an opportunity to give us a number, but we have to read carefully through your eyes. When it comes to refractometers, let us take for example digital refractometers. Digital refractometers, they would also have what we call a range. So a range of measurement or a scale. So as your notes would have said to you that a refractometer measures the sugar concentrations of a solution in degree Brix. And so from 0 to 100 degree Brix. So 100 degree Brix means that it's 100% sugar. So now in this scale of 0 to 100, then we can then have the ability to have different ranges. So one refractometer would have a range of 0 to 32. Another would have a range of 43 to 64. And another would have 0 to 50. And another would have a scale of 52 to 96. So every time you have a refractometer, so you need to check first what is the scale. And number two, you also need to establish what type of refractometer do I have. So we have in some cases refractometers that only measures sugar, and we also have refractometers that can also measure the salt concentrations. For example, the refractometer that I have here is a refractometer that can measure sugar concentrations. And how would I establish that? If you check the refractometer on the inside, you can see the scale there, Brix or percentage mass of sucrose. What I always use to double check, for example, the salt refractometer is always written on the front part. Here we've got salt, which is 0 to 10%. So then I know that this refractometer is measuring the concentration of salt. And salt is always measured in percentage when it comes to refractometer. And then sugar is always degree Brix. So now the question is, say, why would we need to measure the sugar concentrations of a product? Some of you may know that Coca-Cola and some of other beverage manufacturers have decided to change their product formulations and use what we call a no sugar product. So the product would say, for example here, no sugar. So it means they are saying to us there is no sugar, but when you taste the product you can still see there's some sweetness. So they have replaced the sugar sucrose with something else. And we're going to establish that, is it really true that Coca-Cola does not have sugar in the sense of sucrose? And then we can also establish the sugar concentrations of other beverages such as milk, such as fruit juices, and some of the beverages that are juices in nature. So now, what are the things that we need to take into consideration when you are going to operate a refractometer? First of all, a refractometer must always be clean before you even begin to do your analysis. Make sure that your refractometer is rinsed with distilled water or it is cleaned with distilled water, and then you measure the reading of distilled water with 0 to 0. It should give you a 0 reading. Right? So now I want to attempt to measure the sugar or salt concentrations of the substances that I have here in front of me. So we're going to do that. First of all, I'm going to check what is the degree Brix and calibrate my digital refractometer. So the scale that I have here, it says 0 to 45%. So then I can just put in a few drops, not a lot, of distilled water, and then you say 0, and then you say start. And then it should give you a reading of 0, 0. So when you see a reading of 0, 0, then you know that the refractometer is measuring the correct scale. So now I'm going to do this part. So of course, every time you use your refractometer, it should be cleaned. So here we just use a paper towel to clean our refractometer. It's also important because you don't know what was the previous sample that was present in your in the refractometer, or who did the analysis. Maybe somebody did not clean the refractometer, so that is not a good practice, right? So once you have then established now that your refractometer is calibrated, it gives you a 0 reading with distilled water, then you can then begin the analysis. So now I'm going to measure the concentrations of, for example, Coca-Cola, to see how much sugar is present there. So I'm going to use a pasture pipette, then just a few drops here, and then just to cover the whole surface here, and then I can keep this over here, and then my Coca-Cola over there, and then I say measure. And then according to this refractometer, I've got a sugar concentration of 0.1. Then I'm going to go to my digital notebook, and then I'm going to punch in 0.1. Alright, so it's always important that when you get a reading in the laboratory, then you record your results. Record your results. If you don't use a digital notebook, you can also use a manual notebook. That's where we all start. It's not a problem. And then when you are done with your sugar solutions, your first solution, then what you can do is you can clean the refractometer. And then if we want to double check the same solution, so what we can also do is, first of all, we already know that the sugar concentrations in Coca-Cola is even less than 10%. So we can look for a refractometer with a scale which is below 20% or even 30%. So the refractometer that I have here, it's 0 to 50, and then here it's 0 to 60. This is 30 to 60, and then here, if I can check this one, this is 0 to 30. So I can also use this 0 to 30 as a refractometer. So the first thing that you do is to clean your refractometer here, and then you blot it with paper towel, and then from there you just need a drop of sample, and here you can close. And then again, if I use this refractometer, it shows that the line, it's below 0. So basically there is no sugar that is present in this type of a beverage. So you can then discard the sample. So what I just want to emphasize is that the handheld refractometer should always be held horizontally. Hey? So you should always hold it like this, and here you can zoom or you can focus here your refractometer to see the actual numbers. So fellow students, fellow foodies, good students, students of mine, please hold your refractometer vertically. So during the practical, I always see people, they say to me, "Sir, I don't see it. I don't see it." Of course, if you are you're holding your refractometer like this, you're not going to allow the light to pass through the prism. If you're holding your refractometer like this, you're not going to be able to see. The refractometer should always be held horizontally and do not block the light. Eh? So, and then when you are done with your analysis, then you can rinse the prism with distilled water just to make sure that there is no sample that is remaining, and blot it with paper towel, blot it. Be very gentle, gentle. So this is now clean. And when we place refractometers on the table, we place them in this position. Refractometers should never be placed like this. We don't even place refractometers like this. These are expensive equipment, so we need to make sure that we take care of them. So digital refractometer can be used also for products such as yogurt, products such as mayonnaise, products that are semi-liquid, and then these type of products of refractometers, you can also use them for liquid material, right? So refractometer is a very important tool that we use in food analysis in order to determine the concentration of sugar and salt in solutions. Of course, in your practical, you must then use the Pearson square to determine what is the sugar concentration, and then go and use the refractometer to verify that. So yeah, see you on the next video. Don't forget to subscribe, like, share, and comment on these videos. Thank you very much.